Advent of code, day 11. Okay, this is a proper graph. Great. What are we doing with it? How many different paths from you to out? Okay. Uh, count paths. Um, yes. Yeah. Should just be that, right? Hmm. Oh, right. I don't like the look of that. Okay. Okay, that doesn't seem hard. That really doesn't. So we are starting from SVR. We're going to out. Yeah, just that, right? Make sure you're working. You are working. You gave me two. Okay, so let's visit both DAC and FFT in any order. Oh, wait a moment. Oh, no, no, this is easier than that. Um, uh, and yeah, this looks scary and it's not. But can I actually type? Mm-hmm. Mm-hmm. To FFT. Oh, wait a moment. I'm going to assume this. Now going back to server. Sure. Oh, I did that right. Oh, you're still taking forever. Really? Okay. It doesn't need to be a shortest path, right? Okay. Are too dumb. Yep. And here, I'll go back to this. Just in case. Now this one. Oh, right. Yeah, that's what I want, right? Server. Out. Huh? From S. I can't type. Okay, there we go. You're running. Now, which one are you? You're not the very bad one. I'm getting a little worried about how you're going. So what we're also going to do equals that. Plot graph, yes. Directed distance. Honestly, I'm gonna kill that. Wait. G? Directed distance. Really? That's more than a little annoying, actually. You're making no progress. My plot graph, are you not working? If it is a distance, so 2 simple graph. Oh, wait, no, this is not a distance graph. Duh. That does look like a much more complicated graph with crazy cycles. Um, Coloring, I believe, is, yeah. We've got you, 2 out, and we've got a lot of unique paths. Great. Now what if I do from SVR? Actually, do DAC. Let's start with that. And FFT. You show up in here. So there are pivot points. I think scene is what's making this really crazy. Need to find the pivots. That's what I need to do. How bad is my memory? 36. That seems bad. How are you? You're bad. Okay. So what this is... So FFT can get to DAC, but DAC cannot get to FFT. So that's good to know. Stack can get to out. And if we look at this, oh, so it happens to be server to FFT, FFT to DAC, DAC to out. Great. So I want to get all paths. Yeah, do I want shortest paths? No. Yes. So I have to hit DAC. It's only a couple inputs into DAC. That's fine. How is the... Ooh, we're running low. We're running low and you're not converging. So, let's see. I do need to get a slightly different coloring. You can be... I don't know, brown. I am so glad I actually have this. So we start at SVR. SVR can be over here. Ish. So SVR has to get to FFT. All these paths that cannot get to FFT, I don't care about. I must get to FFT. And the paths to FFT, do I even care about you? I actually don't. Use nice, but I don't care. Let's actually start DAC onward. Because DAC has certain paths. We have to get to DAC. Yeah. So, okay. Plan of attack. It's impossible. Yeah, I can do DAC to... I can do that very efficiently. Great, which means I just need to reduce the graph by getting... Oh, yeah, I can... Don't I actually have something for this in graph? So there is a compressed graph, which is just the nodes to keep. I don't care about shortest paths, I care about all paths. So, okay. So what we're gonna do is... any node that we touches and is on a path. But this has distances, and I don't care about distances. Yeah, so the whole thing is I need to compress this. Which is just a can reach. Okay. With no cycles. Oh. Yeah. Okay. There we go. Yeah. Well, true. Not well, true. Make compressed graph. Actually use this. Really? Um, make compressed graph actually goes through and does things. Hold on. Heap queue. No, that's okay. Sorry, make compressed graph is okay, fine. Mm-hmm. Really? Double check. Okay. Mm, okay, actually, take out that. I'll take out FFT. I'll take out SVR. Yeah, FFT. Okay. Um, server. No, DAC'd out. 93. 375. That's what surprises me. Yeah, there's 0 there. So this is what's still slow. Um, from SVR to FFT. No, wait, no. FFT to DAC. That's what's slow. FFT to DAC is great. Um, I mean, I've halved that, which is good. Okay. All right, is the right answer. Good enough. So, oh wow, that surprises me actually, given that problem, how many people solved it already. But yeah, I at least did better than the last couple of days. This is definitely an interesting problem and one that I'm very, very glad I have graph plotting capability for. Um, and there's sound. Okay, so this will be good. This is a complete graph that I can use for purposes later. But let's talk about the problem. If I can go to the right spot. Um, this is quite a mess. Um, so obviously we need to parse the graph first thing. Uh, for part one, we can do just a very simple graph traversal where we count the number of paths, we keep track of what we've seen in this traversal, and we look for paths from a given position uh, to the output and count how many there are. Now, we don't want to actually fully count every single thing. I do wonder, actually. I'll, is it? Is it get info? It's not get info. Is it just info? I don't actually get the cache info. That's what it is. Um, okay, so there are only 613 paths. We actually hit in count paths way more than that. Um, Meaning it's entirely possible that this caching isn't helping us at all, just from the nature of this graph. Um, yeah, because really scene is going to, because this is a directed graph, I was worried about cycles, and it doesn't look like the inputs we have really have cycles. They have just unique paths, which is good and actually probably a thing that can be exploited for computing even faster. But if we had cycles, if on this graph, for example, we could go to PDG, uh, which could go over to, I guess not even cycles, but shortcuts. Um, what shortcuts even matter? Well, no, alternate paths and cycles. So if we had BDG, a path from there to PTH, and a path from PTH to PDG, then, uh, and they both share this MHM. So we could go U to PGD to PTH to MHM, and then carry on, or U to PTH to BGD to MHM, and then carry on. In both of those cases, we took two paths to get to MHM, and of course the path from MHM to out without touching any of these three nodes that we've already been to, the number of ways there is going to be the same. And so if you've got a lot of cases in the entire graph, you can get a ton of duplicate paths. But that doesn't look like it's a characteristic in this graph. So this whole caching thing I'm doing, functools.cache, turns out to not really be necessary. I don't need to keep track of scene. In fact, I am pretty sure if I run this, I get rid of this, I get rid of, well, instead of seeing I do that, I still get 613 because uh, it's just a fully directed graph with no cycles, no loopbacks or anything like that. So this bit kind of overhead, and my guess is that the functools cache for the larger graph, which is again running here, isn't really useful. But yeah, so all that aside, that was what I was worried about here. You don't need to worry about that, it seems. But with that and just a count paths function that just goes and looks for all the different paths, you can get the answer. And thinking about it even more, I was doing a can reach test here. This you can do a reverse traversal and count the number of paths there in part two, which I should have done, uh, but I wasn't thinking about dynamic programming. But yeah, jumping ahead to part two, so we have to go from server to DAC to FFT to out, or server to FFT to DAC to out. Similar to the earlier problem, and my initial idea was do the same as part one, just double check, hey, have we seen all the positions? The problem is the path is much longer, so doing that check kind of slow. But DAC and FFT are kind of checkpoints. FFT you can get into from some nodes, you can get out of it, but once you're out of it, there's no way to go back, and even more importantly, DAC, where in the world of stack DACs over here, once you hit DAC, you are not going back. You can't get back to FFT. I'm sure that some people's solution, well, I shouldn't say I'm sure. I wouldn't be surprised if some people's inputs have DAC come earlier and then FFT come later. But because of that, we can, for my input at least, count all the paths from server to FFT, then all the paths from FFT to DAC, and then finally, all the paths from DAC to out. And because we had to hit both FFT and DAC, we can multiply them together, which is exactly what I do here. And I get out the answer. The important thing is that doing that search, especially for the earlier paths, we need to reduce the graph. Because there's also these side paths that are just not useful. If I'm trying to get the server to FFT, but I start going along one of these side roads, I'm kind of cooked. I'm going to waste all this time traversing the rest of the graph looking, hey, how do I get to FFT? But we can't backtrack. And so, way to deal with that, wrong one, way to deal with that is to have a backwards graph and check, hey, what can we actually, what paths, what nodes can reach the destination? What paths, in the first case, can actually reach FFT? Just going backwards. Get that set, reduce the graph down to that smaller graph. So we've eliminated all these side paths, and then we can do the count paths from before. Now, as I said, I'm pretty sure, thinking about it, that instead of this being just a simple set, this can be a full dynamic programming dictionary of what can reach the destination and the number of paths to that destination. I'll think through that later, and that will probably run faster because it kind of chugs on the FFT to DAC step. But yeah, that is my solution. did take longer than I was hoping, but nowhere's near as bad as the last couple of days. And yeah, I mean, looking here, we're done with day 11, day 12, tomorrow, last day of this event, coming up so much quicker than normal. But I'll be here for that. Hopefully, have a good final day, and that's all I got for today.